We now determine the price that maximize the profit using the price demand function as well as the cost function. So first we write profit function. This equals revenue minus the cost function. And we write revenue equals x times of the price demand function minus the cost function is c. So let's replace this p as we have x times of replace p by the expression 77 minus zero point 0.1 root x minus the cost function is 32x plus 500. This one is a profit function. We can write down this as p of x. Let's simplify this. We have p of x equals, we distribute this x with the terms inside this bracket, and so we get 77x minus zero point 0.1 times root x times x. This we can write down in power form. That is, this one is x raised to the power of 1 by 2, and x is basically 1. So we add the powers, that is 1 plus 1 by 2 is basically equals 3 by 2. So therefore, I write zero point 0.1 times x power 3 by 2 when we multiply x with root x. We then have negative 32x. We expand the bracket, negative 500 here. Let's simplify this. 77x minus 32x is 45x. I write this as the first term, that is negative zero point 0.1 x power 3 by 2. And then 77x minus 32x is 45x minus 500. So we have obtained the profit function. Now we have to determine the x such that the profit is maximum. So we use the calculus, the first derivative test, to determine that. We can find the critical point of this profit function by setting up the derivative of the profit function equals 0. So let's find the derivative of the profit function, which is p prime of x. And this equals, we find the derivative of this expression. I write this negative zero point 0.1, which is a constant. And the derivative of x power 3 by 2 using the power rule is, we put the power in front and then raise x to the power of 3 by 2 minus 1. And so this equals 3 minus 2 by 2, which is half. So this is x power half, plus the derivative of 45x is 45 times the derivative of x is 1. So 45 times is 1 is 45. And then the derivative of negative 500 is 0. So we just ignore that. Let's put this in simple form. So here we have p prime of x. This equals, this 3 by 2 is basically 1.5. And then we multiply this with negative 0 0.1. And it is equal to negative 0.15. So when we multiply negative zero point 0.1 and 3 by 2, we get negative 0.15. We then have x power 1 by 2. This we can write down as square root of x plus 45. So we have obtained the expression for the derivative of the profit function. Now we have to set this up equal to 0. That is, the derivative of profit function equals 0, and solve for x. So let's replace p prime of x equals 0. And so we get negative 0.15 root x plus 45. We solve for x from this equation. We add this expression to both sides. So we get 0.15 root x. This equals 45. We divide by 0.15 first. So it is 45 divided by 0.15. And this equals 300. So we have to solve for x. So here we have root x equals 300. And this means squaring both sides, we get x equals 300 square, which equals 90,000. So when x equal to 90,000 units, the profit is a maximum. In fact, we can also verify that by taking the second derivative of the profit function. So we find the second derivative of the profit function. This equals, we have to find the derivative of this expression. We put this negative 0.15, and the derivative of root x, we can write down this root x as x power 1 by 2. So we find its derivative, and so this gives, we put 1 by 2 x power 1 by 2 minus 1 is negative 1 by 2. So this one is basically 1 divided by 2 times of x power positive 1 by 2, or otherwise 2 root x. So the derivative of root x is 1 over 2 root x, which I put here, plus the derivative of 45 is 0. So we can ignore that. So this is the expression that we get for the second derivative of profit function. And if we put this x equal to 90,000 over here, it's going to be a negative quantity because we have this negative here. So therefore, this one is negative or less than 0 at x equal to 90,000, which confirms that at x equal to 90,000, the profit is maximum. So we have verified that. And so therefore, we can determine the corresponding price which maximize the profit by substituting x equals 90,000 into the price equation. So let's do that. So let's find the price. We have price equals 77 minus zero point 0.1 times the square root of 90,000, and this equals 77 minus zero point 0.1 times square root of 90,000 is 300, and this equals 77 minus zero point 0.1 times 300 is 30. 77 minus 30 is 47. So therefore, this one is in dollars. The price that maximizes the profit is $47.